This video is going to be about how to make a helix on Inventor. So a helix is like a coil or a spring. In Inventor the command is actually called coil, but you should get into the habit of calling it helix, especially in your exams and assignments, because the term that you need to know is helix. So to create a helix, what I need is a sketch of the profile that I'm going to spin around the axis, and I need an axis to spin the profile around. So I'm going to make a little rectangle that is going to be the thing that gets spun round in my helix, and I'm going to make the axis that it's going to be spun round. For the sake of keeping this tidy, I'm going to right click and turn that into a construction line, because it's not really a line that has an outline. It is there purely to give me a reference point for spinning this profile. Now, as always, I could spend time dimensioning this to the right sizes, and I could be dimensioning the distance between the profile and the axis, but for the purpose of this video, I'm just doing it quickly. So to make this profile into a helix, I'm going to use the coil command, which is up in the Create tab. It automatically selects a profile, and I need to pick my axis, like that. And we get a preview of it in green. If you were creating a coil or a helix which needed to be in a certain direction, and this was the wrong direction, you can flip it using the flip command, but I'm going to keep it at that direction. Then we need to go into the coil size tab, and we've got three options to change. We've got pitch, we've got revolution, and we've got taper. Revolution is the number of times that that profile is spun around about the axis. So if I change this to 3, I only see, zoom out, I only see 3 revolutions, because it only goes around it 3 times. If I change this to something like 10, we get a lot more revolutions. Well, we get 10. So I'm going to keep this at 5 revolutions. The pitch is the distance between the revolutions. So at the minute the pitch is set at 10. If I changed it to something like 4, the distance between the revolutions is a lot smaller. If we change it to something like 20, the distance between them is 20 millimeters. I'm going to put it back to 10, and if I click OK, there you go, that's the spring-like feature created. This is your helix. It's getting spun around that axis the number of times that I've requested. So I have 2 other things that I can change and manipulate when I'm using the helix command. If I go back into the coil by double clicking on the model tree, first thing that I can play about with is changing the rotation. So at the minute our coil is spinning in a clockwise direction. If I flip this, my coil is now spinning in an anti-clockwise direction. If I click OK, it's now switched the direction that it's spinning in. The other thing that I can change is the taper angle, which is in coil size. The taper controls how much the helix widens as it goes down the length of the helix. So if I give it a taper of, say, 15, I get a fairly gradual widening of the helix as it goes down. If I change the taper angle to something like 60, it has a much more dramatic effect, and I get a very, very wide, very loose spiral. This can be quite useful for a couple of different things, but it can also produce some quite nice aesthetic effects. If I decide that I want my taper to go in the other direction, I can flip it using this command. Okay, to show you what the helix command can be really useful for, I've got here quite a simple little bottle, and I want to put a thread on the top of the bottle. So I'm going to make a new sketch on a work plane that cuts straight through the middle, because I'm not going to be able to make a sketch on that curved surface. So if I find a work plane that cuts through the middle, and I'll move this about so that I can actually see what I want to work on, and I'm going to use slice graphics again, which lets me cut this profile in half, basically take a section of it, so that I can see inside and actually see what I'm doing. So I right click on the work plane and go to slice graphics. There you go. So now I can see inside the bottle, which is quite useful. First things first, I need to be able to reference this line, so I'm going to use project geometry and grab my line there, and I'm going to want a sort of semicircular profile that I'm going to turn into the thread of my bottle. So zoom in a little bit. So I want a little semicircle, and then I'm going to use the trim to trim it. So there we go, there's my little semicircle, and I am going to pop an axis down the middle. Now my bottle might already have an axis, or I can draw one in. And once again, I'm just going to turn this into a construction line just to keep everything tidy. Finish the sketch, and then I'm going to zoom in again so that we can see this. Now, using the coil command, profile is selected. I want my axis to be this one. Okay, into the coil size. So first things first, I don't want a taper on this because it's going to stay the same diameter the whole way down. I do want to change the pitch though. That pitch is way too big. The 10mm is huge, so I'm going to change that to maybe 4. And the amount of revolutions, there's too many there, so I'm going to change that to 3 and see how that looks. Even then, those revolutions are going down too low, so I think I'm going to change the pitch down to something even smaller, 2.5. Okay, that's looking not too bad. If I click OK, there is a more realistic looking thread for my bottle. And then say I wanted to make the opposite piece, like the lid for the bottle. I've not made a separate bottle lid, but this will show you the idea. Instead of, if I zoom in on this, with my bottle this time, instead of trimming the bit of the circle on the inside, I'm going to trim the bit of the circle on the outside, but it's exactly the same setup otherwise. Finish the sketch. I'm going to click coil, zoom in on this again. Make sure that my axis is that one going through the middle, and this time I'm going to click cut to subtract the material. If I click OK, there we go, there's my helix with the material subtracted.